Hi everyone. In this video, we're going to talk about calculating compound interest. So what is compound interest? It's the interest that's computed on an original investment as well as on any accumulated interest. So for example, this could be reflected in a savings account. So each month you might have something called a dividend that's credited to your account. And what that is it's compounded interest that the bank pays you for banking with them. And so you could also have compound interest on credit card bills or student loans or other things like that. But we are going to focus on the compound interest of investment opportunities in this course. And so, for example, when I do an application problem later on in the video, we're going to be calculating the compound interest of two different investment opportunities to help decide between which one is more beneficial financially. A lot of you thinking about interest, you might think, oh, well, the interest rate, that is the most important thing that I need to think about. It needs to be a higher interest rate so then I can get more money back. But that's not the only thing that we need to consider. It can also be more helpful if the interest is compounded more often. So if it's compounded quarterly or monthly or continuously. When we have continuous compound interest, that is going to require a separate formula from our monthly or quarterly or daily compounded interest. So let's go ahead and look at our formulas. So in the table on the left-hand side, it's the formula for calculating interest for n compounding periods per year. And then the formula on the right is continuous compounding interest. In this formula on the right, I just want to point out that this E is not a variable. It's not an unknown. It's a number. It's that number. You probably have a button for it on your scientific calculator, and it represents the number that's approximately 2.718, something like that. And it's like pi. It represents a number, not an unknown. So let's go ahead and look at what these unknowns or these variables do represent in both of our formulas. So A is going to represent the balance or the amount of money in your account after that compounded interest is calculated and added to your balance. The P is the principal amount or the amount of money that's initially invested. R is your annual interest rate. One thing to note is that you can't just plug in a percent in our formulas. You have to convert it to a decimal first in order to then plug it in. N is the number of compounding periods per year. So like if we have it's compounded monthly, then our N is going to equal 12. If it's compounded quarterly, N will equal 4. If it's compounded daily, N would equal 365. So it just depends on how often that's compounded. And then T represents the number of years. So let's first go ahead and practice identifying from different investment scenarios what the A is, so the amount of money in the account after our interest is accrued, versus our P, which is the starting amount of money, the amount that we initially invest. And then also determine if it's compounded periodically or continuously. And then identifying N if it's compounded periodically. So our first problem is you open a savings account and deposit $250. The account earns 1.5% monthly. How much money is in the account after 10 years? So first off, if we're looking for P, our principal amount, how much we started with in our account? Well, we deposited $250 when we opened it. So that's what we're starting out with. Our A, the amount of money we have in the account after compounded interest has been calculated, well, that's not given in our problem. So in this case, it's just going to remain A. It's unknown. And then the next thing is we're trying to figure out, is it periodically compounded or continuously compounded? And this helps us identify which of those two formulas above we're going to need to be using to solve this. And so in this case, it's compounded periodically because we're told that it earns 1.5% monthly. So this tells me that we're going to use the formula for period compounding, and our period N is going to be 12 since it's monthly. All right, the second question. Your parents invested $500 in a savings account for you in 2010. The savings account is set to compound quarterly. In 2022, the account had a balance of $7,800. What is the annual interest rate of the account? So again, looking for our initial amount that we started with in the account. Well, our parents had invested $500, so that's our starting balance. A is the amount that we have in the account after our compounded interest has been added. And in this case, it actually does give us that amount, which is $7,800. And then next, we need to identify if it's compounded periodically or continuously. And if it's periodically, what is our N that we use in our formula? So in this case, it says that the savings account is set to compound quarterly. So it gives us a period in which it's compounding. So it is periodically compounded, and that period is going to be 4, since it's quarterly, so 4 times a year. Question 3, you invested $1,500 in a CD that pays an annual interest rate of 4.3% and compounds continuously. What is the value of the CD after 6 years? So again, first we're looking for our initial amount, our P. And in this case, we started out with an investment of $1,500. Then we're looking to see, does it give us the A, or the amount that is after interest has been accrued? And in this case, it does not, so it still remains A, or our unknown. And then we need to identify, is it compounded periodically or continuously? And in this case, it tells us it compounds continuously. All right, so now let's go ahead and practice not only identifying these variables from our problem, but also how do we apply these formulas. So our next problem is an application, and we're choosing between 2 savings accounts. So it says you decide to invest $4,500 for 8 years, and you have a choice between 2 different banks. The first bank offers a savings account that pays 1.20% per year, compounded monthly. The second bank offers a savings account that pays 1.15% per year, compounded continuously. Which bank offers the better investment? So first, let's identify our different unknowns. So remember that if it's compounded periodically, we're going to use the formula A equals P times 1 plus R over N to the NT power. And if it's compounded continuously, we're going to use the formula A equals P times E, the number, raised to the RT power. All right, so first off, A and P, do we have those values? Well, in this case, we invest $4,500, so that is going to be our P. And then it does not give us our A. That's something that we need to compute, so that remains unknown. Another thing that will stay the same is that we have that we're investing for 8 years. So that is going to be our T variable. Now, after this, everything is going to be different for our 2 accounts. So let's go ahead and write down what we know for our first bank, or I'll call it bank number 1. So for bank number 1, we are told that it pays 1.2% per year. So that is going to be our R, that's our interest rate. But remember, we can't use our formulas with our percent. We have to convert it to a decimal. And so when we do, remember, if you've forgotten how to convert a percent to a decimal, you need to move the decimal 2 places to the left. So we end up getting 0.0120. And then we're also told that it's compounded monthly. So in this case, we're going to use the compounded periodically formula. So I'll write that down. And since it's compounded monthly, that tells me that my n is going to equal 12. So let's go ahead and plug in what we know. So we have P is our 4,500. R is our interest rate of 0.0120. N is monthly compounded. And then our T is 8. And so if I were to compute this and put this in my scientific calculator, we would get a value of approximately $4,953.18. So this is our total after 8 years. Now we're looking for the better investment, so we're having to compute what the total amount would be in the account after those 8 years for both banks, and then compare. The better investment is going to be the one that has the more money after those 8 years. All right, now let's look at Bank 2. Now, Bank 2, it also is going to have the same initial investment and the same amount of years being compounded, but it says that it offers a savings account with 1.15% interest per year. Again, this is expressed as a percent. We need to convert it to a decimal in order to use it in our formula. So move our decimal place 2 places to the left and we get 0.0115. Then it says that it's compounded continuously. So in this case, we're going to need to use the formula A equals P times E to the RT power. And we have the same initial investment of $4,500 for P. Remember, E is our number. And then our interest rate as a decimal is 0.0115. And we're multiplying that by the number of years invested, which is 8. If I plug this into my calculator, what I get is approximately $4,933.64. And so this is Bank 2's total after 8 years. So now comparing our two bank amounts after 8 years, I see that there is a difference, and Bank 1 actually is going to give us the higher value after 8 years. So in this case, we are going to want to choose Bank 1. And this is why. Now, this could change if you're looking further into the future. If you were asking to decide for your investment of $4,500 after 20 years or 30 years. So make sure that you are answering what the question is asking. So this says for 8 years, so that's all we're going to test is which account has the most money after those 8 years. I hope you find this video helpful and wish you luck as you're considering your future investments.